Chapter 4, Lesson 4 of Pre-Calculus, and I wanted to do an example or two of graphing these sinusoids. I'll probably just do one or two in this example, and then if you need more you can watch these over, or if you need more we can talk about it in class and I'll do another example video. But for right now we'll just do two, and I think we'll pick the cosine here and we'll pick this sine value here. Let's do those two. Alright, a couple of things of review just before we start. Remember the pattern, and this is really going to help you when you're graphing these. Remember the cosine pattern starts out at its maximum, goes to 0, down to its minimum, back to 0, and then back to its maximum. And these normally take place at 0, pi over 2, these quadrantal angles, pi, 3 pi over 2, and then 2 pi. But because we're having stretches and shrinks take place, these values are going to change. So you're going to need to label these points on your graph so that I know that you have the correct placement of the graph. The sine, let me write this up here. The sine pattern, you remember, is where it starts out at 0, goes to its max, back to 0, down to its minimum, and then back to 0. And again, the angle values are the same. It happens at these quadrantal angles, but because we are having stretches or shrink take place, these values are going to change. So we're going to need to understand that. All right. Now, generally speaking, let me just give you kind of how you would do this. If you're graphing, normally what I would like to do, or what I do, is you take a piece or a graph and you stretch it out like here, and both functions break up into 4 even sections. You think about the circle, the quadrantal angles, there's 4 very nice right angle marks, pi over 2, pi, 3 pi over 2, and 2 pi. So we want to put that on here. So if I take this as 2 pi and I divide this in half, 2 pi divided by 2 is pi. And then if I take this one section and I divide it in half, half of pi is half of pi, pi over 2. And then if I divide this in half, I now have these 4 even sections, and I can label these because I know each section is pi over 2 apart. So this is pi over 2, this is 2 pi over 2, which reduces to pi, this is 3 pi over 2, and then this is 4 pi over 2, which is 2 pi. So you'll always want to divide a period into 4 equal parts, and then you have the points where you'll put the pattern. So sine starts at 0, goes to its maximum at the next point, minimum at the next, 0 at the next point, minimum at the next point, and then back to 0. And so if you take a section, divide it into 4 equal, then you have a place to put your point, and you simply put those on there. Now again, because we're having stretches and shrinks, these are going to change. They're going to be different based upon what the stretch or shrink does to the graph. Okay, so let's do a couple of those, as I said, that I have listed up here. And I'm going to do them, sketch them on here, and then I'm going to put them on the graph paper so you kind of see how it stretches or shrinks based upon what we have. All right, so let me get a big eraser here. I need a big one. There we go, big eraser. Let's take care of this. Okay, so let's take this first equation, and this is 2 cosine x over 3. My amplitude is now 2, so when I draw my graph, it's going to go to a height of 2, and I see that we have a horizontal stretch of 3 going on. So what I need to do is to determine the period. And you remember the period is equal to 2 pi over the b value, and the b value here is 1/3. This is the same as 1/3 x. So 2 pi divided by 1/3. Now I need to simplify that. So 2 pi divided by 1/3, that means you multiply by the reciprocal, so the period is 6 pi. So the period of this function is 6 pi, and it's going to go to an amplitude of 2. So once I know that, I can sketch my graph pretty quickly and pretty easily. So let me just get out here a nice little, some straight lines, okay? So we can always do this. And so as I said, what we want to do is to take this horizontal axis here and make it straight, because that's bothering me. Okay, And then we mark out anywhere out here that we want, and we'll call that the period of the function. You remember that's the linear, so linear distance. So this is 6 pi. Now I want to divide this into 4 equal parts. So I divide 6 pi in half. 6 pi in half is 3 pi. And then I want to divide that in half. And so 3 pi divided by 2, or 3 pi divided by a half, is 3 pi over 2. And I divide this section in half as well. So the question is, what is this value here? Well, each of these are equal in measure. They're equal to 3 pi over 2. So if from here to here is 3 pi over 2, then this distance is also 3 pi over 2. So I would add those together. So 3 pi over 2, 6 pi over 2, which reduces to 3. So this is 6 pi over 2, actually. If I add another 3 pi to that, that's 9 pi over 2. And then if I add another 3 pi to that, that's 12 pi over 2, which reduces to 6 pi. So I now have the labels that I want. My amplitude is a height of 2, so my amplitude is 2, and this low value is -2. So I have everything labeled. And now I look, it's the cosine, so I use the cosine pattern. The cosine starts at its max, goes to 0, goes to its minimum, goes back to 0, and ends up back at its max. So I plot those, and now I, let me, come on, draw a nice, smooth, curvy wave, and I kind of messed up the last part of that, so I'm going to try it one more time. So a nice curve goes through the 0 and then back up here. So this would be the graph of the function 2 cosine x over 3, and my period is 6. Now that looks like the normal function, and they're always going to look the same as long as I do this. Let's put this on the regular scale. In other words, this is 3 pi, so if I divided this in thirds, 2 pi would be about right here. Okay? If we think about this, the normal cycle of cosine is 2 pi. Well, 3 pi is right here, so if I divided this section into thirds, it's about right here and about right here, this would be 2 pi about right here. Okay, let's say. Now, normally, the cosine function then would have to do its complete cycle in this, in this one section. So it'd have to come down to here and come back to here and reach its maximum right here. So you can see that this has been really stretched out, as this would be the 2 pi cycle, would be here, but actually it takes all the way out to 6 pi to complete this cycle, rather than completing it in just this 2 pi time frame. Okay, let's take a look at this -4 sine over 2x. Actually, I think we'll look at this one because that one's got a reflection, and we'll save that one for another time. Okay, so if I want to do this sine function, again, I see the amplitude is 4, so it's going to go up to 4 now and down to -4 because that's my amplitude. I see we have a vertical stretch, horizontal stretch of 4, the reciprocal. This is 1 over 4x. Reciprocal of that would be 4, so it's going to stretch that out from 2 pi. So I do need to figure out what's the period then. So the period is 2 pi divided by the b value, which is 1/4. To divide by a fourth, I multiply by the reciprocal, so this is going to be 8 pi. So the period of this function is 8 pi. So I start at 0, I mark a point out here, I'm going to call that 8 pi. I need 4 equal sections, so I'm going to divide that in half, so that's 4 pi. I'm going to divide that in half, that's 2 pi. So each of these sections is 2 pi in length. So this is 2 pi, 4 pi, this would be 6 pi, and then 8 pi. And now I use the sine pattern. The sine starts at 0, goes to its max, back to 0, down to its min, back to 0. So I connect these points in a nice smooth curve, and this is my sine wave. Now again, that looks like a normal sine wave because we stretched out. But what would they normally look like? Well, remember, normally the sine wave is in 2 pi. So in this little section here, if I divided this into 4, it would go from its max, 0, min, 0. So its normal cycle would look like this in 2 pi. So you can see that this has really been stretched out horizontally, taking this side and stretching it all the way out here, where it takes this whole time here in order to make one full cycle, rather than completing it in just this 2 pi cycle. Okay? I wasn't going to, but I'm going to go ahead and do these last two, because I'm just started to have a little bit of fun here, and I just want to keep going. So I'm going to do these last two as well. So let's take a look at those. All right. Let's take a look at this function here. Let's look at this one here, because that last one has a reflection. We'll do that one last. Again, I have an amplitude of 3, so the cosine is going to go up to a height of 3, down to a low of -3. I see it has a stretch. I need to figure out the period. The period is 2 pi over the b value multiplied by the reciprocal, so the period is 4 pi. So I go out here and I mark this as 4 pi. I then divide this into even sections, 4 even sections. Half of 4 pi is 2 pi. Half of 2 pi is pi, so each one of these is pi in length. So this would be pi, 2 pi, this would be 3 pi, and then 4 pi. I use the cosine pattern, max, 0, min, 0, max, and then I draw my wave. Okay, and again, this looks normal because we stretched it out over the normal 2 pi. Normally this would all take place in 2 pi, so if I divide this 2 pi section here into units, then what should have happened normally is it would do all this in here. So again, you can see this horizontal stretch of stretching this out. So let's take one more look at this sine function up here that's been a reflection, and let's tackle that one. And I'm going to erase all this just so it doesn't get in the way. Okay, we're going to do the same thing. We have a amplitude of 4, so this is going to reach a height of 4 and go down to -4. The period is being affected by this horizontal stretch because it's a reciprocal, so 3/2, so it's a stretch of 3/2. So the period is 2 pi divided by 2/3. Now, to figure that out, I need to multiply by the reciprocal. That's 3 over 2. So these reduce, leaving me 3 pi. So the period is 3 pi. So I go out here and I mark 3 pi. And then again, I divide that in half and then that in half to give me my 4 sections. So half of 3 pi is half of 3 pi. Now, if I take half of that, divide it by a half, I multiply by the reciprocal. Okay, so I'm going to divide that in half. So I'm going to it's getting late. I'm going to divide this by 2, which means I multiply by a half. So this is 3 pi over 4. So each of these sections is 3 pi over 4 in length. So 3 pi over 4 would be from here to here. Another 3 pi over 4 would be 6 pi over 4, which reduces to 3 pi over 2. Add another 3 pi over 4 to this, that's going to be 9 pi over 4. And then add another 3 pi over 4 to that, and you have 12 pi over 4, which reduces to 3 pi. So I have the proper units here. Now, it's a sine, so it would be 0 max, 0 min, 0 max, I'll get it, 0 max, 0 min, 0. However, it's a reflection, so everything gets reflected over the x. Sine starts at 0 normally and goes to a max, but because it's reflected, it's going to start at 0, go to its minimum, back to 0, up to its maximum, then back to 0. So the reflection makes it reflect over the x-axis, and so it looks like this. Okay, so that reflection is reflipsing and flipsing. I sound like Schmiegel, or what's his name? Gollum. Flipsies. Precious. Okay, it's getting late. Flipped over the x-axis. Okay, so that's what we have. All right, now again, it looks the same, simply flipped over the x-axis, but again, if we were doing 2 pi, what normally should happen, this should be in 2 pi. So if I was to take this 3 pi here and kind of divide it into thirds, maybe about right here, this should have done all of this in less time, maybe something more like this. So again, you can see how this stretch has stretched that out just a little bit because this value is bigger than 1, so that's a horizontal stretch. So I hope those graphs were helpful, and I hope you get the idea of how to do those. Again, you divide it into 4 parts, label the appropriate points starting with the period, and then make sure your amplitudes are correct, and then watch out for any reflections or over the x-axis.